For example 13, find a point on the graph of f of x is equal to e to the x such that the slope of the tangent line is parallel to y equals 2x. So this is not the tangent line, it's going to be parallel to this tangent line. And you remember something about parallel lines and their slopes? They have the same slope. So our slope here's got to be 2. The slope of this one's 2, so the slope of our tangent line's got to be 2. Okay, so let's come over here so we can do a little bit of math. A little bit of calculus. Here we go. We're going to take f of x equaling e to the x, and if I'm going to get the slope of the tangent line, we need to take the derivative of that function. This is going to be tough. The derivative of e to the x is e to the x. I wonder what the second derivative of e to the x is. I wonder what the 100th derivative of e to the x is. Anyway, so we said that our slope has got to be equal to 2 if it's going to be parallel to that. So we're going to set our derivative equation equal to 2. All right, I've got an exponential equation, and I've got to solve this thing for x. How to get this x out of this exponent? I've got to do the inverse of exponentiating, which is taking the log of both sides. So I'll take the natural log of both sides, and I will have the natural log of 2 is equal to, well, they're supposed to cancel each other out. This is what it would look like, natural log of e to the x. Since this is a composition of inverse functions, they cancel each other out and they give me this x back. So the natural log of 2 is equal to x. In other words, at the point at the point natural log of 2, the slope at that point is going to be this 2 value. Well, if I take my original function, which was e to the x, and I plug in the natural log of 2 into it, I get e to the natural log of 2. And just like we were saying, these things cancel each other out, and I get 2 back. And remember that the peculiar thing about e to the x is that it is its own derivative, which means that on the graph of e to the x, every single y value is the slope at that particular point. So here's the original function, the natural log of 2 plugged in, it spits out the number 2, which is the slope. It's the slope at that particular point here. Let's take a look at some graphs of this. So we have our graph of e to the x, and then specifically at the natural log of 2, the y value is 2, but it's also the slope there. And you can see very prettily that this is the parallel line for our tangent line.